Alright guys, welcome to this video on chapter 8, which talks about non-right angled triangle trigonometry. This is chapter 8 from the IB Mathematics Core Topics SL1 book by He's Mathematics. So let's dive in non-right angled trigonometry. So what do I mean when I say non-right angled trigonometry? Well, in previous chapters we must have seen that for a triangle, if a triangle is something like this, and the angle here is actually something like this, that's 90 degrees, which is defined as a right angle triangle, where you know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But that's not always the case. We're going to get a lot of questions in non-right angle trigonometry. So let's quickly go through the basics of non-right angle trigonometry. So the first part we look at is the unit circle. Now the unit circle is basically a circle with a center of 0, 0, the center here which is 0, 0, and the radius of 1 unit. Now you're not going to really use this unit circle until you do higher level mathematics, and when you define each angle as when you define the angle 30, 45 and 60 as something as a value. But in this, all we need to know is that this is it has a radius of 1 unit, and it basically allows us to calculate. You can use triangles and calculate what cosine and sine values are, which we'll see in a bit. So the equation of a circle, of any circle, of this circle as well, is going to be x squared plus y squared equals 1. That's going to be an equation of a circle. Okay, and I just want to also point out that from this direction, and if you go from this x-axis towards here, that's known as the positive direction, and well, it will be an opposite for the other one. This, if you go from here downwards, that will be a negative direction. Now let's look at how we can define sine and cosine as triangles from these. So if I draw a triangle like I have here, we know that this is actually a right angle triangle when you connect the center to one of this point on the unit circle. So in that case, I can actually define this as 90 degrees, that as theta, and we can say that this length is actually just A. And we can define the y-axis, or the height, as B, or height, or H if you want to. And this side is actually going to be 1, because the radius of the unit circle is 1. So we can actually say this is 1. So if we use our SOHCAHTOA rule, we can see that cosine theta is adjacent over hypotenuse. So it's adjacent to the theta, and then over hypotenuse, which is always the opposite of the 90-degree angle. So in this case, cosine would be adjacent over hypotenuse, a over 1, or a. So this means that a is actually the x-axis. So for any x coordinate of a unit circle, that's going to be cosine. Then we can do the same thing for sine, which is actually opposite. So opposite of theta is b, and then opposite of 90 degrees is 1. So opposite over hypotenuse, which is b over 1, which is b. So from this, what we actually know is that the x coordinate and the y coordinate is cos theta and sine theta. And what I mean is that, let's say if you have the coordinates 2 pi by 3, let's just say, and you have 3 pi by 6, and let's just say, this is going to be your cos value, and this is going to be your sine value on any part of this unit circle. Okay, now that we know what a unit circle is and what cosine and sine values are when we're given coordinates, now let's move on to subtopic B, which is the area of a triangle. Now what we know is that for a right angle triangle, to find the area, it's just half times base times height. So half of a triangle and times the base value and the height. Okay, I don't know what happened there. But of course, this is pretty simple because you can just get a value for b and h, and you can just find out the area, or you're given the value of area and one of these variables, and you have to find out the other. And this is too easy, and it has to be a bit harder. So now we look at the case of finding the area of a non-right angle triangle. So in this case, this is a non-right angle triangle where these angles are actually, none of them are actually 90. It could be close to 90, but it's not 90. So what we can actually do is we can actually draw a midpoint from A to the bottom. Okay, and then we can actually see that now there's two right angle triangles. Okay, so this is 15, or whatever half is 15, it will be this value and that value, because we're actually cutting this triangle in half. But we actually want a better way to calculate the area of a triangle. So the area of a triangle is actually defined as half times A times C times sine theta. Now what these are, so half from our original area of a triangle, A, which is one of the sides given to us, C is the other side which is going to be given to us, and the sine value of the angle which is given to us. So in this case it will be half times 11 times 15 times sine of 28, which approximately gives us 38.7 centimeters as its area. So this is what you have to do when you have a non-right angle triangle. Now again, this is just a formula. We can actually expand further on this, and now we're going to look at what a cosine rule is, which is the next subtopic. So for any triangle A, B, C, the cosine law basically allows us to, the cosine law relates to three sides of a triangle and one of the angles of a triangle. So I'm going to expand on this later, soon, but for now, let's talk about this. So for any triangle ABC, what we can do to find one of these sides, so for example, if I define A as 12, and we have, let's say, B as 14, and we have the angle C as 12, I don't know why. Now, we know that we have A and B, we have to find C. So we actually use this third formula, and we can input the variables. So to find C, the cosine law states that C squared would be equal to A squared, 12 squared, plus 14 squared, minus 2 times 12 times B, because it's 2A and B, and we know that A and B are this, times cosine of the angle, which is 12. And that would give us the side C. And this applies to every single of these other formulas if you've given A and C, or if you're given B and C. Now, what I meant by relating three sides of a triangle and one of the angle is this thing I like to call the angle sandwich, where the angle is sandwiched in between two sides. So here in this example, we can see that 11 and 12 are the sides given to us. We have to find C. Ignore that square. I think that's a mistake. We have to find C, and we've been given 11 and 12. And we also have one of the angles. So we know that, so we can see that this angle is actually sandwiched in between these two sides. So from this, we can actually use the formula right here again, which would be C squared equals 11 squared plus 12 squared minus 2 times 11 times 12, and then times cosine of 30. So this is what actually makes it easier to realize when to use cosine rule, is when you have an angle sandwich like this. But that's not necessarily always the case. So you use cosine law when you have an angle sandwich, but also when you have been given three sides. And now this could be, for example, if I take the same example here and ignore the 30 degrees for this example, and if we define C as now, let's say 15, and we don't know these angles, we don't know 30, okay? Now we have to find one of these angles, because the question will probably say find one of the angles. What we can actually do is when we have three sides and no angles, we can rearrange the cosine law formula and say that the cosine of the angle is equal to b squared. So b squared b squared plus 15 squared minus a squared all over 2 times bc. 2 times 12 times 15 would give us one of the angles. So you use the cosine law, the cosine rule, when you have an angle sandwich like here, or when you have three sides given like that. And of course the a and bc here can be adjusted like this, like right here. Now let's talk about the sine rule. Now the sine rule is a set of equations which connects the length of a side of any triangle with the sines of the angles of the triangle. So let's talk about this quickly. So in this case, we have this triangle ABC, and there are these angles. So we have a triangle ABC, and we have to find these angles. And by using we know that sine is actually opposite of whatever angle we're trying to find. So if you're trying to find A, this is the side, or if you have A, this is the angle you're trying to find. If you have C, the angle, then you're trying to find this side. If you have the side, then you're trying to find this angle. And similar for B. So what this states is that we can now see if this would be equal to this, we can say that sine A will be over the length, which is equal to sine B over its length, sine of B over this length, and sine of C similarly over this length. Or it can be written the other way around as well. Now, to actually solve a sine rule question, usually you'll be given, let's say, if you're using sine, if you're using sine B over B and equals sine A over A, a question might be something like where you're given, I don't know why I did that. So let's say in a question they might give you one of the angles as 11, let's say 11, and the side is 7 centimeters, and you're given sine B, but the side of B opposite to it is 17. So in this case, these are usually kind of questions you'll see for sine law or sine rule, is that you're gonna be given given two sides and one angle, or two angles and one side. And what you want to do is you want to cross multiply. Actually, you don't want to cross multiply. You just want to bring the 17 to this side, or times 17. So the 17 would cancel out. So your final thing would be sine 11 over 7 times 17, which would give you sine of B. And then let's just say that this equals 74 equals sine B. Let's just say it's not an actual value. And then B, we're trying to find B, would be sine inverse of 74. Okay, so that's all you actually need to know for right angle triangle geometry. The ambiguous case of the sine law is actually not really needed again on this level. It's something that you'll see later on. But in general, this is what non-right angle trigonometry looks like. Hope it was helpful.